Hello everyone. This is our seventh lecture, and we are in the week 7 for the NPTEL thermodynamics of fluid phase equilibria. I have uploaded all the 6 lectures on the drive as well as on the YouTube channel of mine, all the 6 recordings. So if you have any problem, you can tell me. So let me wait for a few minutes so that people can join, and then we will start the lecture. So this is week 7. So in last lectures you have read about the concept of statistical mechanics as well, and few concepts about the entropy, how you calculate entropies. So today we will do fugacity questions, and I'll have my own questions which I'll be writing down. You can simultaneously write it down as well, and yes, that's it, and try to solve it. I'll give few minutes as well, and then we will try to answer those questions by solving it in the live session as well. So yeah, let's start the question. So the question number 1, you can start writing with me. It's with me only. So the question is the approximate. So due to the network issue, the chances that the video can get off. So since the time I'm writing down, I'll try to keep my video off because of the network issue, and then we will, like, whenever you want to raise a question, I'll on the video. The approximate value of a gas from its pressure and molar volume is given by the relation as F equals to Vp square by RT, where V is molar volume, the density of gaseous ammonia at 473 Kelvin and 50 bar is 24.3 kg per meter cube. Estimate the fugacity. So take 2 minutes to solve this question by yourself, and then we will try to solve it by us. So this is the question. Hmm? Hmm? Right. Not the class method. Hmm. So yeah, now going back to solving the question. So we have been given F equals to Vp square by RT. So you have been given the density of the gas is equals to 24.3 kg per meter cube. So and temperature you have been given 473 Kelvin and pressure equals to 50 bar. So what do you think? So to calculate the fugacity if you have to calculate F, you need to calculate the molar volume. So what will be the molar volume? So since we know ammonia is the gas, so ammonia molar mass is, we know this, equals to 17 gram per mole, and you can calculate, you should know that per mole how much uh, liters of volume it takes. So this is equals to 17 by 24.3. So this will be in liters, so this will be meter cube per kilomole. So this will be the molar volume. So we know that 1 mole has 17 gram, which in turn has 24.3, or you can calculate from the density itself that kg per meter cube. So putting all this, because you had the density also, so mass per unit volume equals to rho, so mass by rho, so this will be like gram per mole, this is kg per meter cube. So this in turn you can just check the units by yourself and make the calculation. Okay, so now you just have to put the values. This will be, it has been telling 17 by 24.3. So we'll take this thing into p square 50 10 raised to the power 5 square by r 8.314 into t. So this value is p square. This whole value is v, and this whole value is means like this is t and this is r. So we just apply this, what is given to us, vp square by rt. Okay, so going ahead, you can try solving this. You will get this to be, so I have done this thing in Newton per meter square. You should remember that. So I will get around 44.7 into 10 raised to the power 5 Newton per meter square, which will be equals to 44.47 in bar. So this is the answer. Now I hope you understood the question. We just have to apply it. V was also very easy to find. So let's take one question, conceptual question as well. So this question says, question number 2 says, calculate the fugacity of liquid water at 303 Kelvin and 10 bar if the saturation pressure at 303 Kelvin is 4.241 kilopascal and the specific volume of liquid water at 303 Kelvin is 1.004 into 10 raised to the power 3 meter cube per Kelvin per kg. So I'll give you few options also. So A is 0.042, B is 0.011, C is 0.020, and D is 0.009. So what it says, calculate the fugacity of liquid water at 303 Kelvin and 10 bar if saturation pressure at 303 Kelvin is this much and specific volume is also given at the same temperature. So you have been given 2-3 things, the conditions and the specific volume of it. So please try solving this question. So when there is nothing mentioned, so I'll give you a hint. When there is nothing mentioned about vapor, so hint, assume vapor behaves as an ideal gas. So you can take this as hint. It won't be mentioned in the question. Now you try solving it for 2 minutes and then we will solve it. I hope you have tried something. Let's try our own question. So we have been given, so it should always be, let me just take it. I don't know why it is happening this way. Yeah, so I'll take the solution too. So we have been given the specific volume to be equal to 1 point, let me see. Yeah, so specific volume is given to us as 1.004 into 10 raised to power minus 3 meter cube per kg. Our temperature and pressure has been already given, and our saturation pressure, or you can write it as Psat, is equals to 4.241 kilopascal. Okay, so let's start with, so we have been given specific volume of, so we have been asked to calculate FL, liquid water. Okay, so specific volume we need to the molar volume. So since this is water, so the molar mass of water is equals to 18 gram per mole, or 18 kilogram per kilomole. So you need to change specific to molar volume. You just have to multiply by molar mass. So molar volume, okay, you take this as a good understanding. Volume into molar mass is equals to the molar volume. We will understand why we need it. So just for a while, let's take this thing ahead. So specific volume into molar mass equals to molar volume. So let's calculate our molar volume is equals to 1.0004, sorry, 1.004 into 10 raised to power minus 3 meter cube per kg, and molar mass we can put at 18 kg per kilomole if we'll take it. And if we want to cancel the, like only we want kilomoles, so just multiply it by 10 raised to power 3. So I'll just write 1.004 into 10 raised to power minus 3 minus 6 into 18. How much it will be? This will be meter cube per mole. So this will be equals to 18.072 into 10 raised to power minus 6 meter cube per mole. Okay? Yeah. Now, since by the hint we already had, assuming vapor behaves as an ideal gas, we have now P sat is equals to F sat so we have one equation which we should know if we that moves ln F by F sat is equals to V by RT T minus P sat. Okay, now we need to find out the F sat because F so we have to anyways calculate. So taking that in mind, P sat will be equals to F sat, which will be equals to 4.241 kilopascal is equals to 4.241. In this, P should be in bar, like if we are taking that. So taking this index of 10 raised to power minus 3 is equals to 0.0421 bar. So now you don't have to do anything. You just putting all things in value. So I'll put this in equation 1. We have F sat value equals to how much? 0.0421 bar. We have V molar volume equals to 18.0 0.072 into 10 raised to power minus 6 gram per it is meter cube per mole, right? We have P equals to 10 bar. We have R equals to 8.314 and T equals to 303 Kelvin. So putting all the equations, so these are our informations which we have to put. So keeping that, ln F by F sub, which is 0.0424, is equals to V, which is 18.072 into 10 raised to power minus 6 divided by 8.314 into 303 T value, 10 minus 0.0424 into 10 raised to power 5. So 10, what we have been given, 10 was the bar, okay. You change it everything to Pascal, so I have changed it to here in Pascal. So it should be, the unit should be consistent. Nothing should be consistent. So we initially took it in bar or Pascal, whatever. So when you'll solve this, it will be approximately, it will come around 10 raised to power minus 3. This I'm keeping it into bars only. Since we are using 8.314, you have to use it in Pascal or ATM or whatever you can use. So F is equals to E raised to the power 7.1435 into 10 raised to the power minus 3 into 0.0424 bar, which will approximately come to 0.042 bar. This is our solution. Let me see, where is the question? It says A. So let's write the answer as A. I hope you understood this. Let's move to the other question. So we have question number 3. The fugacity of a liquid or a solid is approximately equal to its vapor pressure F. So So what is the condition? So you can also write what is the condition basically. When the fugacity of a liquid or a solid is approximately equal to the vapor pressure. So what should be the answer should be? So this is an informative thing, so I'll just write it. Vapor pressure is not very high. So it was asking the condition basically. The fugacity, when the vapor pressure is not very high, the fugacity of the vapor will be equal to the vapor pressure. Okay, so this was an informative question given to you. Now let's go ahead with another question. So now let's go ahead with our other questions. So question number 4. So this is a big question. And experimental determination of a vapor liquid equilibrium state of ether, that is one component, and acetone, this is the second component, binary mixture. So give x1 is equals to 0.3 at T equals to 40 degrees Celsius and y2 equals to 0.42 at P equals to 10 raised to 5 Pascal. The saturation vapor pressure of the pure component at 40 degrees Celsius are 1.10 raised to power 5 Pascal for ether and 0.56 into 10 raised to power 5 Pascal for acetone. This is 2. Assuming the ideal state for vapor pressure, calculate the excess gives free energy for the liquid phase. Okay, so this is a question: an experimental determination of yearly state of ether and acetone give this values. The saturation pressure has also been given for both. So they asking gives free energy. It's a simple. We need to understand that for ideal state, what it will be. So answer 4. Since ideal state for vapor phase has been given, so we know we can use the Dalton's law and Raoult's law together. So this will be Xi into Pi sat into gamma I. Okay, so since we know x1 equals to 0.3, let's take only the first. T equals to 40 degree and P1 sat is equals to 1.21 into 10 raised to the power 5 Pascal, and the pressure has already been given to us as 10 raised to 5 Pascal, and we were given y2 equals to 0.42. So these are the given things which has been given to us. Okay, so P2 set has also been given to us. Can you tell me what is P2 set? It is 0.56. Okay, yeah, so this has been given to us. So x1 plus y1 equals to 1. Sorry, since we know y1 plus y2 equals to 1, so y1 plus 0.4, which implies y1 is 1 minus 0.42 will be equals to how much? 0.58. Okay, so if for mole fraction for which we will use for ether, is it ether or acetone has been given to us? For ether, if we'll apply this, so this will be y1 p equals to x1 p1 sat into gamma 1. So which implies gamma 1 is equals to y1p divided by x1 p1 sat. So y1 is equals to how much? 0.58. P is equals to 10 raised to the power 5 Pascal. Now x1 to 0.3 into 1.21 into 10 raised to power 5. So which implies gamma 1 is equals to, if you calculate, you will get approximately 0.6. Now similarly, if you do for acetone, it will be Y2P to X2P2 sat to gamma 2, right? So since we already know so x1 plus x2 equals to 1, which implies 0.3 plus x2 equals to 1, which implies x2 equals to 0.7. And we now know that gamma 2 is equals to y2p by x2p2 sat. Now we just have to put all those things. So y2 was 0.42, pressure was 10 raised to power 5. This is x2p2 sat, it's 0.7 into 0.56 into 10 raised to power 5, which implies gamma 2 will be equals to approximately 1.07. Now it's a basic excess gift free energy formula which I'll be writing to you for you so that you can then find out the values. GE by RT is equals to x1 ln gamma 1 plus x2 plus ln gamma 2. Okay, so now going ahead, just putting all these things, G by RT, this is excess gift free energy. Excess, this whole thing is equals to x1 was 0.3 ln of gamma 1 was 1.6 plus x2 was 0.7 into ln of 1.07, which will be equals to 0.19. Therefore, excess gives free energy is equals to 0.19. This is our answer. Okay, isn't it easy? You just have to find all those ideal expression you had to put, and then you were good to go with it. So you can take 1 or 2 minutes to understand the question, and then we will start with our next question. So now let's sorry, we had the access gives free energy for cyclohexane, phenol is given by Then expressions gamma 1 is D. So let's solve this. The energy of cycloid this gives the energy then G by RT is equals to minus 2.1 x1 x2 for activity coefficient G by RT is to del G by RT del Ni N1. By definition, Xi equals to Ni by N G by RT is equals to minus 2.1 N1 N2 by N1 plus N2 whole square. Therefore, N1 plus N2 is equals to N. This can be written as NGE by RT minus 2.1 N2 N1 upon N1 plus N2. As we know, d u by v is equals to v u bar by v square del n ge by rt upon del ni is equals to 2.1 n2 divided by n1 plus n2 minus n1 upon n square. Therefore, n2 2.1 into squared by n square. Therefore, x2 square. This is the solution. Now take question number 6. Methanol, water, vapor, liquid system is at the mole fraction of methanol in liquid is x1 equals to 0.6 and in vapor is y1 equals to 0.8. Vapor pressure of methanol and water at 60 degrees Celsius and 85 kilopascal and 20 kilopascal respectively, assuming vapor phase to be an ideal gas mixture. What is the activity coefficient of water in liquid phase? Using modified Raoult's law, vapor phase is ideal. Y2P equals to X2 P2 sat. So gamma 2 equals to Y2P by X2 P2 sat will be equals to 1 minus 0.8 into 60 divided by 1 minus 0.6 into 20 will be equals to 0.2 into 60 divided by 0.4 into 20, which will be equals to 1.5. What is the axis gives free energy GE in joule per mole of the liquid mixture in question 6. So the continuation question basically. So answer 7. Gamma 1 is equals to Y1P by X1 P1 sat is equals to 0.8 into 60 to 85 equals to 0.94. So GE by RT is equals to X1 ln gamma 1 plus X2 ln gamma 2. So similar way. So divided by GE is to RT X1 ln gamma 1 plus X2 ln gamma 2. So this will be equals to 8.314 by 333 into 0.6 into ln of 0.94 plus 0.4 ln of 1.5. It will be equals to 346.34. So this is the answer of joule per mole. Now question number 8 is for a binary mixture at constant temperature which one of the following between activity coefficient and mole fraction is thermodynamically consistent? So if I'll just put the equations. C, D. And where and D is option 4. So we need to follow one thing equals to 0. So if you do all these things, you will understand that option C only satisfies this condition. So if you want to do this, x1 d ln gamma 1 equals plus. So I'll do that part C part for you. x2 d ln of gamma 2 is equals to dx1 2x1 2x1 square dx1 minus dx1 which is equals to 0. Sorry, this is 8th. Now question number 9. So this is a concept based question. Which of the following answer 9? So the options are A, B, water, both, D, none. So the answer to it is, so this is a remembering question only. So the answer is C. Both the mixtures show are captured well by the Venn model. So now the next question, which will be the last question. Wilson equation is not applicable is not applicable in which of the following cases? So the options are liquid mixtures with no miscibility gap, B is liquid mix with miscibility gaps, C is an acetone, methyl acetate, methanol system at 50 degrees Celsius, D, none of the above. So it is applicable, and so it is applicable, so answer will be B, applicable. Here it is applicable, so answer is B, liquid. Wilson equation is not applicable for liquid mixtures with miscibility gap. The B option is there. This is the all questions which we have done. If you have any questions, any doubts regarding any of these problems which we have done, you can write to me. These are the questions which we have done. So if we'll revise these questions, the approximate value of a gas from its pressure, so you have to just apply F equals to Vp square by RT in this model, where you have taken the molar volume. Here you have taken the specific volume into molar mass equals to molar volume, and then you have applied the formula. Okay. Third was a conceptual question. Third of this was important because ideal state was already assuming, so we have to do, and this was the formula which was of excess gift free energy. So it was given that excess gift free energy, so the activity coefficient will be ln gamma 1. So you just define that the Ni by Ni, and you just have to do it. And then methanol water was the basic question was there about the Gibbs law, and in 7th it was directly related. You have to find out gamma 1 as well. And this question was also related DL and gamma, and 9th and 10th were the conceptual questions which you have to do. If you have any doubts or problem, you can send the comments and the discussion forum. Thank you so much.